Okay, thank you everyone for coming back. I have the pleasure to introduce Doug Turnbull. He's with Daydream, but I think we all know him better as Software Doug, writing numerous blog posts, educating people, writing a book on his shirt, writing another book, or co-authoring another book, AI-powered search that we already heard about. And he's talking about LLM-driven relevance engineering, so the next step of AI as a judge, as I understand it. So very looking forward to the talk.
Great. Thanks. Oh, this mic actually works. All right. Thanks, everyone. Yeah, I think I don't need to say much more than what was said. So you know where to find me, softwaredoug.com. And I will say I have stickers instead of business cards. So if you want a sticker, ChatGPT is an amazing vibe marketing tool. So there's some silly stickers. I am going to be in concert this summer live. Actually, no, I'm teaching a course on doing sort of what I call cheat at search with LLMs. I think there's a lot of opportunity to have more LLMs in the loop at every layer. And sort of as I've done more RAG, it just feels as you go back to regular search, it seems like a no-brainer. So definitely come join. That discount code for $300 off expires at the end of April. So check it out. And yeah, so I'm going to talk about some work I did at Daydream. Daydream is a fashion startup, but a lot of this is it's not necessarily the end all be all of the topic by far. This is like one specific path I went down that seemed to work well for a set of problems I was working on. And yeah, I'm going to talk about how I sort of started down this LLM-as-a-judge path. So I don't know if we need in this group the pitch for LLM-as-a-judge. I mean, we obviously often have labelers, and this is true at Daydream where there's it's a don't have a lot of user traffic. Often when you're getting started building a product, you have some labeling effort, and there are pros and cons to human labelers versus clickstream labelers. That's a whole other conference talk. And you get this data, but then later you are tuning some search results. And of course, what comes up, some novel search results, and you have no idea if these are like any good whatsoever. So we're constantly working around this uncertainty, and it's very annoying. And we have lots of crazy workarounds to try to solve this problem. But with LLMs and LLMs as a judge, as soon as the search results change, we can just have them rejudged. We could say, oh, well, we have some new results. Could my LLM judge maybe come up with some new evaluations for these? And if we trust it, then maybe we can say, oh, did search get better or worse? And that's the general idea. It's a bit of a tighter feedback loop for us. Whereas this earlier situation, maybe we'd have to go and get results re-rated. Maybe we'd have to do something else, or maybe we just give up on offline testing entirely. So the important thing here is that, as we develop a LLM judge, we as search people might be working over here to the right, but we still have this left-hand loop going on. The human labeling doesn't necessarily stop. It's something that guides the LLM judge. And part of that is because on the right, we're going to be sort of building this setup and measuring how accurate LLM judges based on what's on the left. And it's often a case that people start out and they get like 75% accuracy or 80% accuracy on the use cases that you have labels for. And of course, there's going to be new use cases you don't have labels for, and you have no idea where your search stands with regards to those. So this process on the left doesn't go away. In fact, it just makes everything work better to keep it going. And we have to ask the question, like I said, does our judge generalize? We can measure against the human labels to see like how close we are. Of course, like I said, now we have two feedback loops. We have this sort of like LLM judge creation feedback loop, like how good is, and I like to use this term like search oracle, how good is our search oracle at taking a search result and giving us a label at whether or not it's relevant. That is a feedback loop that has to be constantly worked on. It's not a one-off thing. I think I can't remember who, but someone wrote a great article recently on how like LLM as a judge isn't going to magically make your process product process problems go away. It just like is another tool in the toolbox. And of course, like a lot of us have fun on the right when we actually get to actually work on search and using this LLM-as-judge, which is our constantly improving sort of like search oracle, trying to use that to actually improve search. Yeah, so like I said, that's more or less capturing that that's going to be a search oracle. And this is an organizational process. It's not magic. So a lot of things happen, and I don't know, some people may have been at the meetup last night where Eric was showing some LLMs giving labels to search results. This happens with people too. There's a lot of noise when it comes to the classic judgment list. People will debate. When Cupid started, it was a 1 to 10 scale. Like when John Berryman and I were sitting together in an office of a client creating Cupid, it was like, oh, of course, we rate things 1 to 10. But then you start debating what a 5 is, what a 4 is, what a 2 is. And humans often get that wrong. And there's a tremendous amount of noise sort of like trying to measure up to that scale. And of course, an LLM is going to have the same problem. So this is a classic problem. And I'm not going to solve that problem in this talk because I think that is an interesting problem that someone should go and measure and solve. I actually took a step back when I was doing this work and I was saying, like, what is my actual goal? What I really care about is guiding myself during normal manual tuning of search. I want to minimize the cost of human labels. Like, I want to take maximum advantage of what's there by like amplifying. This LLM is like an amplifier of that knowledge. It's like taking that knowledge and like just amplifying out tenfold and generalizing it. And I want to handle the noisiness of the categorical labels, like just the normal problems with categorical labels being, you know, hard to argue by like what a 1 is and what a 2 is and what a 3 is. So a paradigm we don't always hear about as much is doing pairwise comparisons. So you will often see a talk at Haystack or wherever, and you'll get the sort of like, here is a judgment list. And for years, when I would do training, it was, here's a judgment list. And a lot of light bulbs would go off and people would learn about NDCG and this whole system of evaluation. Now, there is another way of thinking about evaluation, which is entirely just based on comparing pairs. Which of these is more relevant to red Adidas Sambas? If I was to do this like with categorical labels and I only saw the one on the right first, there are various biases that might say, oh, that's pretty good. That's a 5. That's like a perfect result. It's red. It's Adidas. But when you compare it to the one on the left, you see, well, that is bright red. That is definitely better. So there is a strong argument that to maybe instead of doing like going through and labeling all these things, maybe what our agent should do is actually compare our products and say like, which of these is more relevant to the other? And there's an interesting article. There's a whole other conference talk that is about where people came up with sort of comparisons versus ordinal labels. Like there's a whole apparently psychological research in that goes back 100 years. But more or less it boils down to pairwise choices are just less noisy because it's harder to make a mistake. But the downside and the reason we do use judgment lists is because instead of rating n things, I have to compare n by n things or n by n minus 1 things to get the same information, right? Yes, exactly. Yeah, you just have, and we're thinking about this as a LLM judge thing where our LLM judge is comparing. Now we have like tremendous complexity in how many things we're comparing. It's just like a lot of comparisons. And Sam Altman is very happy because you're calling OpenAI a bazillion times and he's raking in the dough. Luckily, for me, Apple Silicon being able to run LLMs reasonably well makes this all easier. So using my trusty Apple laptop, and a lot of the code behind this is using the Wayfair annotated data set is at that URL if you're interested. which is furniture, not fashion, but similar. Yeah, so I started to play with some of the models I can run locally on my machine. Apple Silicon runs them relatively fast, and literally I can get to a point where I could try out ideas and walk away and do a bunch of pairwise comparison, of course, cache the crap out of them, and play with search. So still on this left-hand side, because that n by whatever log n is very definitely time consuming for humans, we still get the human raters doing like 1 to 5 or whatever scale you're using. So if human raters are on the left doing 1 to whatever, that can still be training data for a pairwise comparison. And then on the right-hand side, when I'm actually going to the LLM-judge, I can just sort of like see, how well does my pairwise comparison compare to whether, if it chooses left-hand side, well, if the human rating of left-hand side is greater than the human rating of right-hand side, then that's a pairwise win. So you can translate these ordinal labels into pairwise comparisons. And, there's definitely room for improvement on the left-hand side, like the human evaluation process is noisy and needs to be improved and taken care of constantly and handle all the biases that, we've talked about. But as a general benchmark, and the other thing that I've done too is sort of like human rating left-hand side -2 greater than human rating right-hand side. So add a little bit of buffer to make sure it's like, really, this is definitively a better thing and not like in that fuzzy area. So now I can enter in a completely different flow where I'm just comparing search results on the left to search results on the right. And I can do pairwise comparisons side by side to see which of my algorithms tend to be preferred compared to things on the left. And for my purposes, like you can think about this a lot. What tended to work well for me when doing this, if you're curious, is literally just row by row comparing. And what if for some reason the left-hand side wins once and then the right-hand side wins the next one, eventually it's you sort of see a general sense of like averaged over the 5, which one was preferred row by row. And that actually tended to work pretty well for my situation. So now the question becomes, if we all agree that this is a reasonable course of action to take, what prompt do we use? So what prompt do we use? Do we use the product image? Do we use a category? Do we use reviews? And there's a million things we could do. And I tried all of them. I tried every field individually. And this is the precision when I just ask it to force it to do left-hand side or right-hand side. This is on the Wayfair data set. And you can see different things matter more. Name seems to matter more. If I just literally say, here is a product of, I don't know if I have the prompt here, but here is a product. You can imagine just basically this, but only including the name. And same thing with the description, the product category, the product class. And to take a step back, because I didn't draw a big picture for you, you may start to see in your mind like, wow, if I actually break this down into like judges that focus on individual attributes, I have a really amazing tool, not just to just judge search results, but to judge each of these features that are part of my search algorithm. How good is name how much does name matter for my LLM judge to agree with my human raters? Like which of these actually causes most agreement with human raters? So just keep that in your mind. And if I like literally create a judge that's all fields in the Wayfair data set, I get to 78.1%. And I take a step back. This is all using Qwen 2.5 locally. So the 7 billion model, fairly common. Now, if you follow my blog, you may have seen some of this stuff and you know that there's variations, but the thing that turns out to matter as well is checking both sides. So giving the left-hand side product as the right-hand side and vice versa. And when you do that, the precision goes up, but you have a lower recall. So you have a set of that whatever at the top row, the 42% or whatever, that 42% is where the left-hand side and right-hand side, when you swap those, didn't agree. But when you swap them and you get the same result swapped, you get a much higher precision. So within that set, you get like 88%, and then 42%, the LLM, more or less, this process would say, I don't know, which is interesting. So you put all these things together, you see the all fields, you get closer to 91%. And this is a big insight of doing this work when you do pairwise work, is giving our LLMs judges the ability to say, I don't know. Like, I'm not sure what the answer is. And you will have higher precision, although on less data. We can take this a step further. And this is really where the aha moment came up for me, which is we have a title judge, a description judge, and this thing that we're trying to predict, which is a human preference. And if you've ever done normal, boring machine learning, this starts to look familiar, because the title judge and the description judge start to look like features, and the human preference is a predictor. And, you know, you can imagine numerically we slot out left-hand side for -1, right-hand side for 1, and neither for 0. And all we're doing is literally predicting the human preference given really stupid judges. So we have a judge that's focused on title, a judge that's focused on description, and so on. And if we keep going with this, we have a title judge, a description judge. We can build, if we train something like a decision tree, and there's other models you can train. You can train like a gradient boosting model, which is a set of decision trees. But you can come out with a decision tree model that takes as features each judge's result, and come out with a probability that the answer is left-hand side or right-hand side. So that's ultimately what spits out. And in the same way we allow sort of like it to say, I don't know, we can set a threshold of saying like when it's greater than 0.9 for left-hand side, then we say it's left-hand side. If it's greater than 0.9 for right-hand side, we say it's right-hand side. And anything in between, we allow it to say, I don't know. So we have a model now that sort of like uses attributes of the data to make a prediction about about what the human label would be for this thing. And so I like this because it's sort of like less LLM-as-a-judge and more LLM as feature engineering for text kinds of attributes. And the judge is actually more how we put those together and have them relate to each other. Yeah, so because I have to prove that I wrote code once, features, and trying to predict that, yeah. And all this is in the GitHub repo I was talking about. So now when we train this, and like I said, we say p greater than 0.9 for whichever, we get a much higher precision, slightly lower recall. So we can push that precision up for like, get it to 44.9%. And you can actually play just like any decision tree. You can play with permutations of features, like some subset of this, or some, whatever. And I should say trained on above, but not the all fields as a feature. That is something you could do, but it's kind of makes things less interesting. So the main thing, though, is accuracy of this isn't the point. The point is I have insight into how the features of my documents and sort of how they relate to the queries, their relationship, how that translates into our human judge's perception of relevance. So yeah, these are the original features. And so what does this enable us to do? And I may be like super early. You guys may be lucky. This allows us to do something like we have our PM notices 10% of queries mention color. So what do? we have some eval for red Adidas Sambas, and we only get certain level of accuracy compared to the human eval. It's only a certain level of agreement. We can add the color as a part of the document, or we pull it in from some other system. Somehow we know the color of the thing, and we can now use this to build a judge. This is what maybe the judge. Which of these is more relevant for the query? Red Adidas Sambas, left-hand side color, right-hand side color, brown, and it will spit out left-hand side, right-hand side. We can add this to the mix, and we can see the actual impact. Maybe we see better predicts human labels by 2%. And we see that color has maybe an outsized impact on the decision tree eval. We have a sense for how it matters in the ranking function. Search is also often very nonlinear. So you might say, oh, if the name would typically prefer the left-hand side, then maybe we look at color. Often there's like this is a bit of a misrepresentation. The actual decision trees also have a left-hand side, right-hand side, and I don't know. But there is a sort of, based on that, you can eventually navigate down and sort of, you could see that in a certain situation, color really matters. And in other situations, it maybe doesn't matter at all. So maybe there was like, I don't know, somehow we were in shoes, or for specific categories, we might be able to figure this out. And these numbers are made up. But you might imagine that all of a sudden we're explaining much more of the data with a higher level of precision by adding this feature. And it starts to look like we are starting to build a feedback loop for what will actually improve search relevance without actually doing any search relevance work. So if we add our colors, decision tree explains more of the problem. And none of this, we haven't done, the only thing we've done is add color to the index. So maybe we don't even have to do that. Maybe we have to extract the color if we don't know it. But we can start to look into things like how would we balance it? How would it fit into to our ranking algorithm that we might build? And how we haven't done the work of actually like, how would we construct a query? Maybe, how would we use embeddings for color? Would we like somehow just use the text match? Like, is there some color similarity space we have to think about? We haven't done any of that work that is like the interesting work that we often do. We've just sort of like thrown color in, and an LLM knows, we hope, a good LLM will know color being close to each other or not. So just to put this all together, LLM-driven relevance engineering. We start out with a naive solution for search. We add a new judge for some attribute. We add that to the index, I should say. We observe an impact to its agreement with the humans. We see maybe it explains more of the human labels, our sort of LLM-judge ensemble. And this and we see how it fits into the structure of the problem. And then we continue with our next feature. So now we move on to like, does recency matter for our situation? We create a judge just for which of these is more relevant. And the other thing, before I close with that amazing image, the other thing that is important to keep in mind, I've done all of this with LLMs, but what if recency was literally like a snippet of code that said like, is this greater than or less than, like we somehow could explicitly parse out the date from the query, and we just literally said, is this greater than or less than? Any of these are just like any pairwise feature comparisons. So with that, I hope you come to my course, and I have lots of stickers up here. I hope you get a sticker, and yeah, come chat with me, or I guess ask questions. I'm totally open.
Thank you, Doug. Do we have any questions for Doug? Yeah. Let me come around.
Hey, thanks for the talk. You mentioned that you're using Qwen 2.57b. I'm
Yeah.
just curious, was it the 7b? Was it Qwen? What made you chose that model specifically?
I tried a bunch of stuff until it worked, and I was like, this seems to work, and it's relatively fast. And I actually went down a route. At first, it was like I wanted image support, and there are Qwen visual language models out there that have stuff, and then I couldn't get that to work, but I was still in Qwen. So this is the usual decision-making process of a software developer, sort of like I kept going until it worked, but nothing too systematic.
So the interpretability of a decision tree is really nice, but what would you do if your decision is, let's say, you're retrieving query document pair where you have dense text and not a product with defined features?
You have query document pair.
And the document is like a chunk of text, and I need to recall the 5 most relevant documents.
Oh yeah, that's interesting. Yeah, so this, I will say, like, what I went through here definitely makes a lot more sense for structured, like a lot of e-commerce search is very structured in this way, where there's a lot of structured stuff. So that becomes interesting. So let's like think about that. There's more work to be done with that chunk of text. So maybe there are things like other features we might want to pull out of that text. So that doesn't get rid of the feature engineering part of that, where you're trying, like, what topics are mentioned in this, or like what like, I don't know, what the how formal is it written, or there's all kinds of things like that, or even just like trying different embedding models. Like literally one of the things that could work is a simple cosine similarity, and say is left hand as like one of these nodes could be as cosine similarity between query and text to see, like, is left hand side closer or right hand side closer to the query.
Any more questions?
Oh, Stavros always has questions.
He looks too relaxed.
He looks too relaxed. He's thinking of a zinger. That's true.
Uh, Hey there, really nice talk. And I was just curious, like with e-commerce data, there is also a lot of ranking signals, like
Yeah.
those kind of things come into picture, and sometimes click ratings are more relevant than human judgments. But let's say if I want to leverage some model like this, do you have any recommendations about, or maybe just use ranking signals as judge features, or like what would you recommend using there?
That's a really good question, and I'm curious. I'd be really curious, like, if other people in the room have experience with this, because I generally haven't seen people go the LLM-as-a-judge route, but focused on clickstream as a ground truth. It's usually, maybe because everyone's building AI products that no one uses yet. It's usually it's usually LLM-as-a-judge with human ratings. But I would really be interested to see if the same principles apply as that as a ground source. But like even in that case, what could be interesting, mostly as an exploratory feature, is if you had human labelers and you were trying to see, does your click like whatever feature agree with them, like which one gets more engagement? If you had some way of measuring that, how that agrees with if you use that as a feature, how well that agrees with your human labelers.
Do you have a question?
Thanks, Doug. Always a pleasure to hear you talk. You seem to get the really important stuff out in this wonderful way. I was wondering about a particular case where we talk about red shoes. Red shoes and sneakers. Red's red. It's bright red. Talk about red shoes in, let's say, men's dress shoes. There is no bright red. There's burgundy, there's ox blood, and so on. So something that's, if you try to compare red sneakers with red dress shoes, the dress shoes will never be considered red. So how do you deal with that? And you say, well, this guy is looking for red leather shoes. They're clearly not looking for bright red, but my ratings were all based on, pairwise comparison. This is clearly red and this is clearly not. But in fact, it is in this subset of the documents.
That's a great question. I think that's where, in the decision tree structure, I would hope that some sense of category would be more relevant than like you would have a query that was like red leather sneakers, and category left-hand side would be, I don't know, athletic footwear, and the other right-hand side would be dress shoes. And that feature, I hope, would be...
Who's generating that feature on that decision tree?
So in this case, I would assume, so there's an assumption that the category exists on my part. So if you do have a category in your index that's like, this is I'm taking from the index the category of the left-hand side, which is an athletic wear, and the category on the right-hand side, which is some kind of dress shoe thing, then that judge is probably going to say, well, the product that is dress shoes is more relevant. Now, what should happen, the reason the decision tree is appealing, or some kind of structure, some kind of model, is, well, maybe in the cases of, so that takes care of like most of the uncertainty in the decision tree, because like that helps you figure that out. And then you get down to the side that is, these are, I've already preferred the category, so I already prefer like one of these as category, so I'm like the rights category, and now I'm in a color node there in the decision tree. Now that color node may have a different sense of impact in there, because you're saying like, okay, right hand side, the dress shoe was preferred, that category was preferred. Now let's look at color in the context of, I prefer the right hand side's category, and that is in that case, you would hope that you've taken most of the uncertainty around with a category, and you're only taking a little bit of the uncertainty out with the color. Now, you're absolutely right. If we only look at color, it will collapse. It will be like, is this more red than that? Then that's where the color by itself is not particularly useful.
Okay. Yeah, we got one more question.
Thanks. Good talk, Doug. Can you talk about how this scales?
Like scales in terms of?
Yeah, like very large corpora.
Yeah.
You'd wind up having huge numbers of categories and huge numbers of LLM judges for features and that.
Yeah.
It seems like it's really well adapted to smaller type corpora that have orthogonal sorts of feature criteria, where a large corpora where it's much less defined would probably be more difficult.
Yeah, for sure. So in my case, I'm usually working with millions of documents that fit in a laptop. So in that case, and the other thing is I'm comparing, let's say for one query, there's like 100 labels or something. So you have 100 log 100, so 100 times 10, 1,000 potential comparisons or something. And then you multiply that by however many queries and however many judges. So it doesn't necessarily, it's not particularly with a lot of caching. So that sounds like a lot when you multiply all those numbers. When you add in a fair amount of caching and you're doing this like a few queries at a time and that kind of thing, it tends to be reasonable as a local guide for me when doing like ad hoc development. I don't think it's a replacement for like a larger scale process.
Okay, thank you.
Yeah, sure.
Hi, thanks for that. I was just curious about catalogs that are more dynamic. So a lot of these sites are obviously new products all the time, new products leaving, or old products leaving, and that kind of thing. And do you see a process to kind of optimize for that churn?
Yeah, so like you have a situation where that's a situation where I would almost want to be much more clickstream evaluation focused too, because if you're taking a clickstream sense of ground truth and you have products coming and going, like this was the case at Reddit. Like Reddit is extremely fluid. Like the search results for a popular political figure will change thousands of times a day, just based on whatever news is happening. And so for us, we were constantly, for the far left-hand side, we were always like, what is the point in time at which this is evaluated is an extremely important aspect. It's like part of the query. When you get to the right and you have a LLM and things are trending in and out and moving in and out, that's a case where LLMs might not be a great tool, because LLMs aren't necessarily going to be keeping up with what exactly was happening on May 3rd, 2024. I don't know. Someone's going to tell me something terrible happened that day. This might be a case where LLM-judge is not the best case scenario. I think an LLM-judge is reasonable when you are focused on the kinds of problems that a human rater would help you with. Because when you get to very subtle things like, I tell this story a lot, but at Reddit, when people search for Cybertruck, human evaluators think people want Cybertruck products, but often people want silly videos of Cybertrucks when you look at engagement data. And this is something you learn just looking at the data of actual user engagement. And I suspect an LLM would be like the human and not have any sense of how the clickstream, the subtle revealed preferences in the clickstream data would do.
Should I take another one? Yep.
Yeah, go for it. Oh. Mm-hmm.
Yeah, thanks for the talk. Now that you have all those signals, do you have recommendation to use them in a simple way, for example, in lexical search, for example, to filter on a color or category, or to use them to boost some attributes that you judge as important attributes, so that you boost them to be in the top, in like a function score query, to boost them to be on the top results, for example? Do you have recommendation to do that without using a re-ranker, for example, just in a simple way in a lexical query?
Yeah, definitely. I mean, the book on my T-shirt probably has a lot of that, because in Relevant Search I talk a lot about that. And I honestly think there's a lot of RAG. There's sort of a renaissance in the like boring old ways of just doing manual relevance tuning. But like one technique, for example, that often works well is this idea of tiering. So you have different priorities of results. So tiering is there's a often in information retrieval, things come in layers. So you often have your first high recall layer, and then you have a higher precision layer but lower recall, and so on. And you start at this high recall layer, and you start pulling things up into the next layer that are like important, and there are layers to this thing. So, and people implement this sort of like several passes. You might hear like L0, L1, L2 ranking phases, eventually maybe a machine learning model that's really focused. But honestly, it's as much about selecting those first, do a fair amount of query understanding and content understanding. So let's say that there is an attribute like color that is really important to your users. And you learn this because you saw a talk by Doug Turnbull, and you tried these great ideas and they were fantastic. Now you take that and you say like, oh, I have a color issue here. Well, the first thing we need to make sure that we do is we have in our retrieval set candidates that are reasonable color matches, which may already be the case. So let's say we do. We've retrieved maybe with some first pass basic ranking. It might be like an embedding, might be an image embedding, might be just BM25. So the next thing we do is we start to look at like, okay, within that, are there things that are for this query? This is where query understanding becomes really important. For this query, let's say color, how important, we have to ask a question, how important is color? Is it more important that the results all be the same color? Or is it more important that they all be the same item type? And then within that, sort of tie break based on color. So let's say they're like, it's much more important that this is all the same item type. So we we might like make sure that the top N are like very similar to the item type. So we're like, I don't know, couches or sofas. Everything is in that, and maybe we don't have our taxonomy that deeply. So then the next thing we do is we might say, okay, well, what is a good color match? How are we actually doing that? And we might have to think about what is the similarity space. And it's not, I don't necessarily mean embedding similarity space, but like in colors, like red there are types of red. What are the phrases that might tend to match up to that? But you start to think like, can I create a similarity space between different definitions of color so that like pink is close to red and orange is a little bit farther, and all the way over here we have blue. And you could look into how to do that. There's a lot of stuff written about that. And then we start to say, if it's kind of more of a tiebreakery boost, we do the same thing on our content too. We have this on our query and we have this on our content. And the similarity space is basically saying, like, I've used the tools of the search engine to produce a score that will maybe 0 to 1 or 0 to 10 or something. So then we have to figure out how are we going to add that. So we add that, maybe we add that as a boost with like a low weight, a higher weight. And all of this is sort of like in this supported framework of evaluation that we have that's kind of like guiding this process. Like, are we going in the right direction? Are we not? And if it is kind of a tiebreaker boost, then it's more about like nudging things up and down a little bit just to get the right colors closer and the wrong colors farther down. So that's like a very abstract answer, but that's kind of how I think about it.
Okay, thank you, Doug, for the talk and for taking so many questions.